Hi, my name is Mike and I'm a product specialist with Expo. In this video I'm going to demonstrate Expo's single-ended dispersion tester, the FTB 5700. As we know, chromatic and polarization mode dispersion can be real system limiters for 10 gig and 40 gig non-coherent systems and can still cause issues with the new 100 gig systems. So, knowing the CD and PMD of the fiber is still very important. The 5700 offers some unique advantages over the dual-ended systems on the market. Firstly, being single-ended, you only need one engineer to perform the test. So this reduces OPEX and saves time, as you don't need to wait for the other engineer to get to the other end of the link with the light source. Secondly, you can test multiple links heading in different directions from one location, again meaning fewer truck rolls and reduced OPEX. The 5700 is a fully automated CD and PMD tester based upon international standards. It's suitable for testing all types of single-mode fiber, has a dynamic range good enough for metro, core and long-haul testing. Additionally, its accuracy means it's suitable for 10, 40 gig and 100 gig certification. Let me show you how it works. This is the main test page. As you can see, it's a very simple GUI with no complex setup. So as long as the engineer can clean, inspect and connect the patch cord, they are assured of a correct test. The engineer simply selects whether they want CD, PMD or both. They fill in their fiber and cable information and select the pass-fail threshold they want applied. Within the pass-fail menu, we have some predefined limits for 10 and 40 gig and some 10 gig Ethernet limits. We also have the option to define your own limits based upon your own network or system tolerances. Then we press start. Firstly, the unit measures the length of the link using OTDR technology and will use this value to automatically calculate the CD and PMD coefficients. This is something you don't get with the dual-ended techniques. Once it has the length, it moves on to measuring the CD of the fiber. It's using a time of flight technique, FOTP 175B. In this case, it's using 8 wavelengths across the S, C and L band. And it's because we are using 8 wavelengths that gives the result a very good uncertainty. Once the CD measurement is complete, it moves straight onto the PMD test. This test is based on a relatively new technique developed by Expo and ratified by the EIA-TIA standards body in 2009. This technique, FOTP 243, involves the unit sending pairs of wavelengths with the same state of polarization and measuring the difference in polarization information when the pairs return from the end of the link. The process is repeated many times with different wavelengths and different states of polarization, and this information is used to compute the PMD of the link. The PMD measurement takes longer than the CD because we are sending lots of pairs of wavelengths rather than just 8 wavelengths as in the CD. Once complete, we have all the information we need. We have the length of the link, we have the CD at 1550, we have the dispersion slope and the coefficient. In this case, we have 16.96 picoseconds per nanometer per kilometer. And from experience, we can tell that it's G652 standard single-mode fiber. Being able to identify which fiber type we have is very important for 100 gig systems employing Raman, as the Raman performance is different with different fiber types. For the PMD, we get the total PMD, a second order PMD, and also the PMD coefficient. In this case, we can see that we have a low PMD link in both PMD and PMD coefficient. I can now save the result and click Report to generate a final report. So as you can see, dispersion testing with Expo's single-ended dispersion tester is a very easy way to characterize your fibers for CD and PMD. Thank you for watching.